Integral calculus. Consider a variable force Fx acts on a particle in its motion along x-axis from x equals to a to x equals to b. Consider we have to calculate the work done by this force. Here the graph is shown. This line represents the force Fx. Fx means that force depends upon the distance. That is, it is a function of distance, and this represent the this axis represent the distance x. Now if the force is not variable, then work done will be force into displacement as shown in this figure. Here force is not variable, so directly we can calculate work done force into displacement. Here force b f into b minus a, from here to here is b, and this represent a, and so this distance will be b minus a, and it is equal to area of the rectangle AABAB. Now consider the case for variable force. To calculate the force in this case, calculate the work in this case, we divide the interval a to b in long number n of a small interval as shown in the figure. This represents force and this represents distance, and force is variable, that is force depend upon distance, and this is the graph between force and distance. Now this graph is divided into several strips, small strips of n number of small strips, and here we consider a strip with length is delta x, and its position is xi minus 1 and xi. The area under the curve is thus divided into n strips. Each strip is approximately a rectangle. As the variation of fx over a strip is negligible, if we take n to be very large, that is n tends to infinity, then the strip will also uh, be so thin that the difference between fxi and fxi minus 1 is vanishingly small. So the area of ith strip will be delta ai equal to fxi into xi minus xi minus 1 or fxi into delta x. To find the total area, we can add up the area of all these strips. Hence, the total area under the curve is a equals to sigma I equals to n delta ai equals to sigma I equals to n fxi into delta x. The limit of this sum as n tends to infinity is known as the integral of fx over x from a to b. It is written as a equals to integration a to b fx dx, where b is the upper limit, a is the lower limit, and fx dx definite integral between a and b. If we remove the lower and upper limit imposed, the integral is called indefinite integration and can be written as integration fx dx. Now the area is a equals to integration fx dx. Mathematically, integration is reverse process of differentiation. That is, differentiation of fx dx equals to fx. Then integration of f, here this f is small and this f is capital. Then integration of fx dx equals to fx. For example, if differentiate sin x, then d sin x by dx equals to cos x, and then If we integrate cos x, then we will get sin x. That is integration of fx dx equal to fx. So integration of cos x dx equals to sin x. This symbol represents the integration of symbol with respect to given function. Here dx, it means the integration is over the function which is a function of x. That is integration of given function with respect to x. Note, if we have y equals to sin x plus c, then dy dx sin x plus c equals to cos x plus 0 equals to cos x. Since integration of capital Fx dx equal to small fx, hence integration of cos x dx is equal to sin x plus c, where c is called integration constant. As at present, we should neglect the integral constant in integration. Now we have some formula which we have to remember. Since we have differentiation of x to the power n, which is written as dx to the power n by dx, and its value is n into x to the power n minus 1. So when we integrate this, we get this value. So we can write dx to the power n by dx equals to n plus 1 into x into n plus 1 minus 1 equals to n plus 1 into x to the power n. Hence integration of n plus 1 into x to the power n dx will be equal to x to the power n plus 1. This imply n plus 1 into integration of x to the power n dx equals to x to the power n plus 1. Hence integration of x to the power n dx will be x to the power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. So this is the formula for integration of x to the power n. Whenever we have such type of function, we directly use the formula, this formula, that is integration of x to the power n dx equals to x to the power n plus 1 divided by n plus 1 plus c. C is an integral constant. For example, here integration of x square dx. So using this formula will be x to the power 2 plus 1, because n plus 1, and divided by n plus 1, n here n is equal to, so 2 plus 1 and plus c, and will be equal to x cube by 3 plus c. So integration of काम है